Good day everyone. I'm Carlo A Lopez from Grade 12 Ephesians. I am here to report about waves. These are the different types of waves, like the mechanical waves and the wave from the disturbance of the water. Let's try to do a simple experiment about waves. The first thing to understand about wave is that they transfer energy from one place to another, but they don't transfer any matter. So when light waves pass from a phone screen to your eye, or sound waves pass from the speaker to your ear, only energy is being transferred. Sometimes, too, we can interpret that energy as a meaningful information, which is why our brain is able to build up images and tunes from the light and sound that it receives. To travel from one place to another, the waves vibrate or oscillate, as we can see in this displacement distance graph. The distance is how far the wave has traveled from the starting point, while the displacement is how far from the equilibrium point the wave has oscillated. So how far it's gone up or down. The maximum displacement is known as the amplitude, while the distance of one entire oscillation is called the wavelength. So that could be from equilibrium, up, down, and back up. Or it could be from the very top of a wave, which we call the crest, down and back up to the next crest. It just has to be one entire oscillation, and the opposite of the crest is called the trough. Now, sometimes you might see a displacement time graph instead, which looks pretty much the same. But because we have time on the x-axis instead of distance, the length of one complete oscillation will be the time period instead of the wavelength. And the time period is just the time it takes for one complete oscillation. The benefit of knowing the time period is that we can then use the equation here to work out frequency, which is measured in hertz and is a number of complete oscillation per second. To see how it works, imagine that each oscillation takes 0.5 seconds, or in another word, the time period is 0.5 seconds. This means that there must be a total of 2 oscillations per second. So the frequency is 2, which is what we'd get if we did 1 divided by the time period of 0.5. We can also use the equation the other way around. So time period equals 1 over frequency. So if we were told that the frequency of a wave was 4 Hz, which means 4 oscillations per second. The medium can be solid, liquid, gas, or a combination. However, not all waves need a medium. Light and radio wave can travel without a medium, while mechanical waves can only travel through a medium. We have transverse and longitudinal waves, also called compressional waves. Thank you for watching. Thank you very much. Bye.